All right, so here we're going to be dividing, and so we use what's known as the quotient rule, since quotient is the answer to division. And you guys remember from yesterday that when we were multiplying, we added the exponents as long as the bases were the same. And so since dividing is the opposite or inverse operation of multiplying, hopefully then it makes sense that we are going to subtract the exponents. So pretty straightforward then. So 5 take away 3 would make x to the second. 12 take away 2, k to the 10th. If it is the same, then it is equal to 1. Not 1 is an exponent, but just the constant 1. So this would be the same as saying m to the 0, 3 minus 3, and anything to the 0 power is equal to 1. Not 0, 1. And I think maybe at the very beginning of class at some point we kind of had a little conversation about why that is. Thinking about exponents and how when we come back down, if we were dividing, when we did like 2 divided by 2, it would be 1, not 0. So anything divided by itself, hopefully it makes sense that that's equal to 1. So you don't need to write m to the 0 first. If you see that it's exactly the same top and the bottom, you can just say 1. So if there's more than one variable, we're just going to subtract each of those separately, like when we added them separately yesterday. If it's first power, then I can simply write b. I don't have to actually put a 1 with it. It's okay if you do, but typically you won't see that. So here, p to the third and q to the fourth. And then when you have this whole series of variables multiplied together in that monomial, if something has the same exponent, it just won't be a part of your answer. We don't need to write a 1 in the front or a 1 in the middle. We're going to subtract our x's, those exponents, subtract the y's exponents. The y's basically cancel out. And then z. So we would have x to the 15th and z. In these first examples, we should have variables only on the top, but we are going to see situations today with negative exponents, but we never want to give our final answer with the negative exponent. So when we see things where there's a higher exponent in the denominator, then we're going to end up leaving it in the denominator. So if we have coefficients, just like yesterday, those big numbers in front, those coefficients, do not behave the same way as the exponent. So it is still division, which means we might actually be able to divide, or we need to reduce if we can't divide. So if we can divide, we'll divide to get a whole number. But if we can't divide, we reduce that fraction. So 6 over 2, I can divide to get 3, and then subtract my exponents, so that's just 3x. Keep in mind the ones without exponents have 1s, so this would be 2, and then r and s. Or you could say r to the first, s to the first. But you do take 1 off of each of those for the r and the s that was in the denominator. Negative 36 divided by 4, negative 9. The c's cancel out because they have the same exponent. And then d, 5 take away 3 is 2. 2 negatives in a fraction, just like we saw when we were doing slope, makes a positive. So for those coefficients. And then x to the first power, so simply x, y to the second power, and z doesn't get anything subtracted, so it's still z. And then 11 and 12, we just have to reduce. So I could make this 1/2, or I could simply write the 2 on the bottom and then n to the 4th. So that, or this. We will have things later where the n to the 4th, if the higher power was in the denominator, and that's why either write it in the very top or kind of by the middle. We want to be sure that it doesn't look like it's down in the denominator with the 2. 36/54. So 18 is actually the largest number that goes into both of those. That ABC button on the calculator or your fraction button, like Alyssa has a fraction button, I'm pretty sure if she puts 36/54 and then hits equal, it will reduce for you. 2/3. Then subtract the exponents on the m's and subtract the exponents on the n's. Now, in this case, because there's only a 3 in the bottom, you would not necessarily have to extend this, but we are going to have things later in just a few minutes, really, where we will have variables on top and bottom, and so then we would just want to make sure we just extend that fraction bar. So, big numbers in a fraction, we are dividing or reducing the fraction. We are subtracting the exponents because division, opposite operation of multiplication. So with multiplication, we added exponents, so here we'll subtract. Mixed practice. Now we get to use more than one rule. If there is an exponent on the outside of parentheses, we want to take care of that before we use the quotient rule. So the top of this one, 3 to the second, 9, and then x to the 5 times 2 is 10. The bottom is the same at that point, and then it becomes a problem like the ones we were just doing. So then 9/27 is the same as 1/3, or just a 3 on the bottom. X, 10 minus 3 is 7. You would not have to have that 1 there if the x is part of the fraction. If you kind of move the x off the fraction, then yeah, you need the 1 there to make sure it still looks like a fraction. So simplify the top. So 2 to the 3rd power, that's 8. Multiply the exponents. And then the bottom is staying the same, so maybe you rewrite it, maybe you don't. So this would be 2, a to the 3rd, b to the 5th. No longer a fraction because our coefficient and all our exponents were bigger at the top. We could have exponents on the outside and have to use power rule also on the bottom, or in number 16 on the top and the bottom. If there was one, giant parenthesis and one exponent on the outside, you could simplify inside first. But if they each have their own separate, we need to make sure we get rid of that before we use quotient rule. So this part will become 16 w to the 2nd v to the 2nd, remembering they both have 1s to start with. And now, I'm just going to rewrite this so I see it together. 12/16, you can divide them both by 4. That reduces to 3/4. 9 minus 2 is 7. 4 minus 2 is 2. And this could just stop here, or you could extend it all the way across. Both things mean the same. And then in 16, it's like a 3-for-1 problem. We're going to use power rule on the top, power rule on the bottom. and then use quotient rule. So 2 to the 4th power, 16. C, I've got 1 times 4 makes that C to the 4th. D, 4 times 4, so 16. So remember power rule, it's kind of a little bit like distributing because every part of that monomial gets raised to the power. And then on the bottom, 2 to the 2nd is 4. And then C, 2 times 2 is 4. D, 3 times 2 is 6. Then we go to the new thing, 16 divided by 4. The C's are canceled out because they're both 4th power. And then D to the 10th. So final answer, much smaller and simpler than where we started. Okay, we're going to do just a couple of them on the next page, and then we're going to be doing the evens. Okay, the evens on homework 3. If you've already started and you did some extra, the ones at the beginning are not, they're not very time consuming, but so I want to show you, for instance, number 17, there are actually 2 valid ways to do this. I can get rid of the exponent on the outside first, but notice what's different now. It's 1 giant parentheses to the 3rd power. It's not just on the top. It's not different for the top and the bottom. So rather than making everything bigger, I could simplify what's inside first and make this 1 over 2, or simply a 2 on the bottom. Subtract those exponents, and now take this to the 3rd power and get m6 and 3 over 8. Don't forget the 2 doesn't behave like the exponents. So let's see if we had done it the other way. If we had done 2 to the 3rd power is 8, 12 and 6, and on the bottom 4 to the 3rd power, 64. 2 times 3 is 6, 1 times 3 3, and then we reduce 8 over 64, leaves an 8 in the bottom, or 1/8, which is the same thing. 12 take away 6 is 6, 6 take away 3 is 3. So both ways have, you get to the same place. The downside of the second way I showed you is like this number and this number, now they're getting bigger, and it may not be as obvious about how they reduce. So if I go ahead and do 12 and 15 to the 2nd power in number 18, that's going to be harder to reduce than if I just reduce 12 over 15, divide by 3, divide by 3, k to the 4th. So if I can make it smaller first, if it's all in one big set like that, it may be easier to make it smaller first and then use the power rule at the end. You should get the same answer either way. We don't always have a choice. So the ones on the front side of the page, we did not have that choice because the parenthesis and the exponent on the outside was not on the entire thing. So we can only do it, use the simplify inside, then the power rule at the end if everything is inside the parenthesis. Oh, goodness, thank you. Oh. All right. Let's see if there, what I got here. Let's see, number 20. So let's look down and look at number 27 on this page, because that will be somewhat like what you're going to run into on number 20 in the homework. So we got all kinds of steps to do. We get to use power rule and product rule and quotient rule, and then we get to subtract all in one problem. So in this case, we've got separate exponents in different places, so we do need to do power rule first. So first I'm going to look at this part and get 8m to the 6th. So 2 to the 3rd, and then multiply the exponent. Then I'm looking at this. 3 to the 3rd, so 27 n to the 12th. And then all of that's getting divided by this. Now, you can multiply 8 times 27, but if I didn't have a calculator in my hand, I would prefer to do this. I mean, personally. I'm going to take the 9 into the 27 and then just do 8 times 3. So then I have 8 times 3 is 24. And then even before I squish them together, I can go ahead and subtract my m's. 6 minus 4 is 2. Subtract my n's, because I really couldn't use product rule because they weren't the same variable. 12 minus 7 is 5. And then I can, don't forget, we've still got that 18m squared n to the 5th. And then I'm happy to see that those are like terms, because otherwise I could not do that subtraction. And so my final answer, 6m squared n to the 5th. So 20 is kind of like that. Again, I could have done 8 times 27 and got, 216, and then 216 divided by 9 is 24. But I had to actually stop and think about what 8 times 27 was. I could do 9 goes into 27, and then 3 times 8, easier, personally. All right, so take a few and evens on page 10. That's homework 3 for Unit 4. Just the evens on that page. And then we're going to look at negative exponents on page 11.